Hi there, 7th graders, and welcome to video lesson 4.4a, the distributive property. You might remember simplifying using this property last year and calling it feed the birds. Right now at this point, please be sure that you have your notes open to lesson 4.4a. If you don't have them, pause the video now and go ahead and find them. We're going to begin by just taking a look at simplifying expressions in general. And then why do we need to use the distributive property? What's the purpose? There are three ways to simplify any numerical expression. You could first just use order of operations. So if I had the expression 2 times the quantity 4 plus 6, I could add the 4 and 6 first to get 10, and then multiply 10 by 2 and get 20. I could also look at the meaning of multiplication. Multiplication means groups of. So if I have 2 times the quantity 4 plus 6, it's really two groups of 4 plus 6. One group of 4 plus 6 is 10. A second group of 4 plus 6 is also 10, giving you a combined total of 20. The third way to simplify a numerical expression is by using the distributive property. When I multiply 2 times the quantity 4 plus 6, I can first multiply 2 times 4 and get 8, and then I multiply 2 times positive 6 and get positive 12, and 8 and 12 make 20. So now let's take a look. Why do we need to use the distributive property when we could just use order of operations or groups of numbers? Well, in this same example, 2 times the quantity 4 plus 6. Of course, using order of operations when everything is a number would be the wisest choice. But what if the 4 were an x? Now could you use order of operations? Could you add the x and 6 together? No, you couldn't because they're not like terms. So in cases like this, the distributive property is the only way in which we can simplify an expression when there's an unknown variable. And by simplifying, we will get rid of the parentheses by applying the distributive property. So let's give this a try. Let's start by simplifying some expressions using the distributive property in our notes. I'd like you to copy down problem number 1. 3 times the quantity x plus 2. Now this also means 3 groups of x plus 2. So if I have 3 groups of x plus 2, just to give you a visual of what that looks like, let's try distributing. First we take 3 times x. And 3 times x means 3 groups of x, which would just give us 3x. Then I would take 3 times positive 2. So here I'm going to circle those 3 groups of positive 2. If you have 3 groups of positive 2, you have a total of positive 6. 3x plus 6 would be the expression in simplified form. I can't add the 3x and the 6 together because those are not like terms. Let's try number 2. Go ahead and copy number 2. 4 times the quantity n minus 5, or I can think of this as 4 groups of n minus 5. So I'm going to put 4 groups of n minus 5 up here. Now to distribute, I'm going to take the 4 and multiply it by n, 4 groups of n. I'm going to circle that. So if I have 4 groups of n, I would have 4n. Now I'm going to take the 4 and I'm going to multiply it by the negative 5, 4 groups of negative 5. So if I circle 4 groups of negative 5, I would have negative 20. 4n minus 20 would be the simplified expression. I can't combine those two together because they both are not like terms. Let's try a few more. I'd like you to write down example number 3 and 4 in your notes while I get ready to do those with you. All right, here we got 3 and 4. Let's give this a try. I have 5 groups of x plus 2a. So I want to multiply the 5 by both of the terms inside of the parentheses, by the x and also the positive 2a. Remember last year when you did this, you said feed the birds, right? Here's the mama bird, it's got to feed this baby bird and this baby bird also, right? So I'm going to take 5 times the very first term inside this quantity. 5 times x, 5 groups of x. That would just be written algebraically as 5x. Now I'm going to take 5 and I'm going to multiply it by positive 2a. 5 times positive 2a. Well, that's 5 groups of 2a. 5 times 2 is positive 10. I would have positive 10a. Think if I just move this over here, I'm taking 5 times 2a. Remember, 2a is also multiplication. So I really can take 5 times 2 and get 10, and then a. 5x plus 10a. Now ask yourself, can you combine those terms together? Are they like each other? No, they're not, so I can't combine them together. This would be my simplified expression. However, if I write it the professional way, the 10a should come first because in alphabetical order, a comes before x. So I'm just going to reverse my terms and write it like this. Let's try number 4. Here we're taking x times the quantity 12 plus y. All right, we're taking x and we want to multiply it by everything inside the parentheses because remember, this is multiplication when it's sitting next to the parenthesis. So I want to first take x and multiply it by 12. X times 12 is just 12x. I reverse them around and put the number in front, 12x. Now I'm going to take x and also multiply it by positive y. X times positive y. Well, that's going to give me a positive result. X times y, I can just write as x, y. I want to be sure I put those in alphabetical order. I don't even need a dot in between. Just by sticking them together, I know there's an invisible operation of multiply. So now I end up with 12x plus xy. Can I combine the terms together? Nope, they don't have the exact same variable. This is an x and this is an xy. So I'm going to leave them separate, and this is as simplified as I can get. There we have it. All right, let's try number 5. Ooh, go ahead and take a second to jot down number 5. If you need to pause the video, you sure can. Wow, we've got c and we're multiplying it by this entire quantity inside the parentheses. How many terms do you see in there? 1, 2, and 3. So we got this mama bird here that's got to feed 1, 2, and 3 baby birds. You can't forget about any one of those. All right, let's begin. First, we're going to take c and multiply it by the first term, b. C times b. Now, if I take c times b, because of the commutative property, I could flip them around and say b times c. I'm going to do that. I'm going to write them in alphabetical order. B, c. B times c. All right, next I've got c, and I'm going to multiply it now by positive 7. Well, I'm going to get a positive result, so I'm going to put a plus sign down. And c times 7, so think, do we write c times 7 like this? Nope, we always want the number in front, so 7c. Lastly, I've got c, and I'm going to multiply it all the way over here by this last term, positive 2d. Well, I know if this is positive and this is positive, I'm going to get a positive result. C times 2d. C times 2d. Remember, this is multiply also. I'm multiplying all 3 of these together. The number should always come first, so I have the number, and then c times d in alphabetical order, 2cd, and I'm going to stick them all together. Now take a look at the 3 terms that we have. Do you notice here in these 3 terms that none of them are like terms? This is a BC, a C, and a CD. No like terms at all. So I'm going to keep them all separate. But by simplifying, by using the distributive property, I've created an expression that no longer has parentheses. And that's one of the reasons we use distributive property, is to get rid of those parentheses. Let's try number 6. Oh, there's a fraction in there. Here we have half times the quantity 10 plus 6x. Remember, this is multiply. I want to multiply 1/2 by everything inside of the parentheses, the 10 and the positive 6x. Now, when I take 1/2 times 10, remember, times is the same thing as the word of. So I could think, what is half of 10? And then I don't need to use a calculator. Half of 10 is 5. Half times 10 is also 5. Now I'm going to take half and multiply it by positive 6x. What is half of 6 x's? Well, if I have 6 x's, half of them would be 3 x's, positive 3 x's. So I end up with 5 plus 3x. Now I'm going to flip the order around and I'm going to put the variable first, 3x plus 5, to write it more in the professional way. And then this would be my simplified expression. No longer do I have parentheses. Let's try negative, hold on. I think I have number 7 here before we get to negative numbers. We'll get there. Okay, one more here with a fraction. Go ahead and pause the video if you need to catch up and write it down. Okay, let's see if we can distribute and simplify here. 1/3 times the entire quantity. We've got 3 terms in there, 3k, 9, and a positive 15n. Remember, we want to multiply 1/3 by all 3 of those terms, just like you guys fed the baby birds last year. Okay, let's begin. 1/3 times 3k. Now again, when you think of the word times or multiply, I want you to think of the word of. 1/3 times 3k, or a third of 3k. What's a third of 3? Well, a third of 3 would be 1. 1k. Now, do I need the 1 in front of it? Not necessarily. No, you wouldn't need the 1. If I put the 1 in front of it, it would just be 1k, and we know that because they're stuck together, it's multiply. What is 1 times any number? Well, it's the number itself. 1 times k would just be k. Okay, so I wouldn't need to write anything in front. It is just assumed that if I see a variable with no coefficient in front, that there's 1. All right, let's do the next one. 1/3 of positive 9. What's a third of 9? Well, a third of 9 would be 3, positive 3. And then we have a third of positive 15n. A third of 15n. Well, that would be positive. What's a third of 15? Think of this as a third of 15 nickels. How many nickels would that be? A third of 15 is 5. There would be 5 nickels. So I want to bring the variable with it also. Now look at the 3 terms we have. This one has a k, 1k. 3 does not have any variable at all. And this is an n. None of them can be combined together. We always want to check to see if we can combine like terms, and we can't. Now let's rearrange these terms to put this more in the professional way. Which letter would come first in the alphabet? K. So I write K first. Then next would be N plus 5N. And lastly would be our constant term, plus 3. Alphabetical order and constant last. There we have our expression. Very good. All right. Now what we're going to do is we're going to go on to 3 examples with negative numbers. Number 8, 9, and 10. Go ahead, pause the video, and write down number 8, 9, and 10. Copy the problems into your notes. If you'd like to give them a try on your own and then come back to the video and see if you are right, you absolutely can do that. All right, let's give them a try. And if you did these on your own, that is awesome. Let's see if you did it right. So we got negative 3 times n. Negative 3 times n is negative 3n. I'm simply just putting them together. I don't need any dot or time sign in between at all. Now, careful with this here. I've got negative 3, and I'm multiplying it by positive 5. Notice the sign in front tells me that this is a positive 5. Negative 3 times positive 5. Now, with multiplication, I can think, do signs agree or do they disagree? And here they disagree. They're different, so negative answer, negative 15. And remember, you can always use a calculator to help you out if you want to type in negative 3 times 5 into the calculator. So negative 3 times positive 5, negative 15. And then I just take a look and see, can I combine them together? Negative 3n minus 15? Nope, they're not like terms. So there is my simplified expression. And I have my variable in front and my constant last. Let's try number 9. Now I'm distributing negative 4 times the quantity x minus 7. Okay, so first let's do negative 4 times x. I would write that as negative 4x. Remember, when I'm multiplying a number and a variable, I can just stick them right together. Now I have negative 4 times, look in front, negative 7. I always look in front of the number to tell if it's positive or negative. That's why I'm circling that. Negative 4 times negative 7. Here the signs agree, so my answer is positive. 4 times 7 is 28. Same thing if I took in the calculator, negative 4. Nope, I got to turn it on. Negative 4 times negative 7. I'd get positive 28. So I'm going to write a plus 28. Now I look and see I got negative 4x plus 28. Can I combine them together? Nope, there's not an x here. They're not like terms. So this would be my simplified expression. Notice that by applying the distributive property, I no longer have parentheses. All right, last one. Here I've got 6 times the entire quantity in the parentheses. There are 3 terms here. So let's see if we can do this last one here. Some negatives, negative 2k and a negative n. Let's give it a try. 6 times 7. Well, that's an easy one. Use a calculator if you need to. 42. You ready? Now we're going to feed the next baby bird. 6 times, look in front, I like to circle the term, 6 times negative 2k. So think I've got 6 times negative 2k. Remember, this is being multiplied, being that they're stuck together. So I can take 6 times negative 2. I know 6 times negative 2 is negative 12. And then don't forget to multiply that k. Bring down that k with it. All right, lastly, 6 times negative n. So 6 times negative n, 6 times negative n. Well, remember, this is a 1 in front of the n that we don't see. So 6 times negative 1 would be negative 6n. So I bring down that n with it. Kind of tricky there. Now take a look and see what we have. 42, negative 12k, and a negative 6n. None of them are like terms, but let's rearrange the order to write this in a more professional manner. Remember, in front of the 42, that's a positive. Okay, so what letter comes first in the alphabet? I think it's K, so I've got a negative 12K. I'm going to write that first. Next, I would have a negative 6Y. I write that next. And lastly, I would have a plus 42. I write that last. So now that I've got my terms all in the correct order, alphabetical, constant last, I'm ready to circle my simplified answer. All right, I think we've done pretty good here, haven't we? We worked pretty hard. Hopefully, you feel pretty good about our goal today, being able to use distributive property to simplify expressions. You can go ahead now and you can practice the 4.4a practice assignment in Schoology. Good luck and have fun. Feed the birds.